Hello everyone. Hey, I just wanted to make a quick video for you guys to kind of go over relays a little bit better. I'm hoping you guys are kind of, getting a grasp of some of this electrical stuff a little bit by now. But a relay is something that is one of probably the most overlooked devices in a circuit. And it's also probably one of the devices that most people don't actually understand. I've seen people try to wire up fog lights on their cars or spotlights on their LED bars on their trucks, and they just want to run it in a circuit with straight to a switched power. That's not good because that's a high load going through that. That bulb or those fog lights or that light bar or whatever it may be, accessory you're putting on your car or the factory's adding to a car, is going to be a high current device. So we use relays to control that. All right, so relays, remember about a relay. A relay is a device that uses a low amperage, low current circuit to control a higher current or higher amperage current. All right, so it's basically just like we're using a switch to turn on a relay, which is like another switch to control a higher amperage circuit. That way we don't have to run nearly as much high gauge high current wire through a vehicle, so it saves on that. We can mount a relay closer to, say for example, maybe it's a starter motor or something that draws a lot of current. We can mount this relay closer to that component, and that limits the amount of high current wire that we need. It's also saves switches and everything like that, because now you don't have a lot of high current constantly going on and off through that switch. All right, so I wanted to go over this a little bit here today. I've got a couple things set up here. I know it looks kind of crazy. I've got wires all over the table here, meters and stuff, but I wanted to show you a couple ways to test this. Of course, the first easiest way to test something, if you think that maybe a relay in the fuse box is bad and a component's not working, let's just use a horn for example. If the horn's not working and you want to check the relay real quick, a lot of times if you find another relay in that fuse box that matches the relay, but it has to match completely. All right, because there are different style relays. I have a bunch of different ones over here with different pin setups. These are both 4 pins, they just are a different style. I have some with 5 pins. The blades are in different positions, so you have to make sure it's the same one. But if I look and it's the same number and there's one sitting right next to it, maybe the fog lights use the same relay. I could take the 2 and switch them and see if the horn starts working. That's a quick little check, all right? But another way to check it and to further your diagnostics to see if it's a relay problem or if it's a component problem, I'm going to show you a couple little tricks here you can do. I'm also going to show you a special tool in the next video that we can use for that too. And then I also have another little test kit that I'll show you in another video. But for right now, I want to show you the method that you can use. Anybody can use with just having a multimeter and a test light and some jumper leads, okay? So first of all, we have to look at the schematic. Most relays have a schematic right on the side. So this is going to tell me that pins 85 and 86 are the control circuit. All right, that's where the control coil is. We're going to switch that power on. It's going to energize that coil, make a magnetic field, and pull the switch shut, which runs through terminals 87 and 30. All right, so I'm going to get this hooked up. One of the first things you could do is a continuity check. So I'm going to do a continuity check on the coil side. So I'm going to go to pins 85 and 86. See if I can find them here. 85 and 86. And I'm going to turn my meter on to ohms. As you guys can all see here, I have my meter on the ohm setting. My test leads are set up correctly down at the bottom. All right, I am going to try and set this up so you guys can see it. Hopefully you guys can see that. I'm gonna take my 2 leads, touch them together, see what we have. All right, it zeroes out, so we know that our connections are all good here. And I'm gonna find terminals 85 and 86. So let's go to 85s right here. And 86 should be opposite of it. All right, so let's see what happens here. Okay, we have about 75, 76 ohms of resistance it's showing right there. All right, so that's not bad. That's actually probably where it should be. Usually most of the time on the control circuit, you're gonna see somewhere between 50 to 120 ohms. If you see less than that 50 ohms reading on most relays, you should probably suspect that the relay is the problem, but the problem is actually on the control side because that coil actually does not have enough resistance. Remember, we're trying to build a little resistance in there to create a magnetic field to pull that switch shut. So if it's less than 50, it's probably a problem. We're at 70 some, 75, 76, we're in good shape, okay? So that was a quick little check. Now, an operational check with a test light is good to use because the test light is actually going to force current through the relay because this little light in here, even though it's real little, this little light is actually going to cause a current draw. So it's going to force current to go through the relay. So I just have a jump pack set up here. You can do this with a 12-volt battery in a car. A lot of times I just test it on the hood of a car. But I have a 12-volt car jump starter right here. So what we're going to do is I have my red jumper lead hooked up to my positive side of my 12 volts. So I'm going to put it on terminal 85. And I'm going to pull these. I always like to have these sleeves down so that way the terminals don't touch and cause sparks and damage. All right, so we're going to go 85. Put that one on 85. And then I have my black test lead hooked up to the negative side of the jump pack or the negative side of the 12-volt power source, the ground. And that's going to go to 86. I don't know if you guys can hear that or not, but when I touch them, you'll hear a click. That's the switch inside. That's telling me that the coil inside is energizing, it is creating the magnetic field, and the switch is moving. But that doesn't tell me that the relay is actually working. Maybe there's resistance built up inside the contacts on the switch side. Maybe the switch is moving and clicking, but it's not actually making enough contact for the current to flow through. There could be some different things going on there. So most techs make the mistake, they do this, and they stop here. They're like, oh, the relay's good, it's clicking. Not necessarily. So what we're gonna do is I'm gonna hook this one up permanently to it. Put that on there, get my hands off of it. So now I can use my test light. Now, I have another jumper lead over here hooked up to my 12-volt power source, and I'm going to hook that to either terminal 87 or 30. It doesn't matter which one, all right? But that's the switch side. This would be the side that is controlling the high current circuit, all right? So we have that now closed because we have it clicked. The switch is pulled closed from the control side. I'm gonna hook power to this side, and this test light should light up when I touch this terminal. And it does. All right, turn it off for you guys to see. So this tells me that this is a good relay. This is a good relay because we have the control side powered up, the coil is energized, the magnetic field is created, it clicks, pulls the switch shut with the magnetic field. I introduced power to the switch side, and coming out of the relay is power. Like I said, the test light's good to use for this test because it forces current through here. Now I could use my meter too, hook it up to a ground, and test available voltage coming out of here. And do that method too. But this works just as good, just as easy, and it gives you an operational check to know that, hey, that relay is good. All right, let me disconnect all this. Now I have a relay here with the cover off of it. And what I want to do is I want to show you a little bit of how this works, all right? So, let me get my little pocket screwdriver here. Here's your pins down at the bottom, obviously. And all this is the covers off of it, so it makes it easier to see. Here's all your wire coiled up, right? That's gonna be what the control side is. When we put a low current, 12 volts to pins 85 and 86 on this relay, it's going to energize this coil, which is now going to create a magnetic field and close this switch to control the higher current side. Okay, so let's set this up and see if we can get this to do that. I Power should be on. I got positive side. Let's put it on 85. My negative side, let's find 86. Now normally you wouldn't have the cover off of this to do this. This is just so you guys can see it work. All right. So hopefully you guys will be able to see this. If you want to touch it, a little switch move. We power up the control side. It energizes this coil winding of wire, creates a magnetic field, and pulls the switch shut. All right. Hope this helps a little bit, doing a quick check on some relays. If you have a test light, some jumper leads, and a 12-volt power source, anybody can check a relay at home. Takes a couple minutes to do. I would recommend always check it because these don't go bad all the time, but they do go bad sometimes. And I've seen guys replace expensive parts like starter motors and other components because the relay was bad and they didn't check it. They just thought it had no power down there. They just thought that maybe the starter was bad and they just started shooting parts on the car. That's not the right way to fix a car. All right? Do your operational checks, check the relay, take a couple minutes, check it out. Something any of you guys can do. All right? Next video is going to be showing you the Relay Buddy tool and how much easier that is to do, but not everybody has that tool. All right? So keep this in mind. Hope this helps. Check it out. Wortman out.